The empty chunk scenario, how would I end up with a lot of empty chunks lying around and screwing up my balancing and making the balancer think that everything's in order when in fact it isn't? Well, there's a couple of ways. First, you could make a pre-splitting mistake. You can create thousands of erroneous chunks, basically, screw up the pre-splitting. The other one that's a little bit more subtle and sort of the trap that more people fall into, if you've got a time-based shard key, also referred to in most cases as a monotonically increasing shard key, because it doesn't have to be time based, it could just be something that always increases over time, also bad. But the reason why I'm saying time based shard key here is because the other sort of requirement for empty chunks to occur is that you're using some sort of time based shard key, be it the object ID or something else, and then you're periodically deleting data, old data. So this doesn't sound like a terribly bad thing, right? And it seems like quite a common use case, right? So maybe you've decided that, okay, well, I don't really mind about hot chunks and I don't mind about limiting my write capacity. I just want to shard based on this nice key that I like, and I'm willing to deal with the consequences. And what you're doing every once in a while is going back and deleting your old data more than 3 months old, more than 6 months old, that kind of thing. Well, let's see how that actually plays into how the balancer works. I'm going to start with a single shard. We'll call this shard 1. And you shard it on underscore ID. Having known all the caveats, you've still decided that you're going to shard on underscore ID. And you've been adding data to shard 1 as you go along. And so you've got 500 chunks on shard 1. Then you start to run out of capacity. You're like, okay, well, this is the whole reason I went on with a single shard solution in the first place, to make it easy for me to add capacity. So you start to see some stress on the system, so you add a second shard. This is your new shard, and what's going to happen is the balancer is going to kick in. It's up here, it's running on a MongoS. It's going to kick in, and it's going to take chunks from here. So far, so good. But what do we know about the balancer? Well, we know that the balancer will pick the shard with the most chunks and move it to the shard with the least chunks. In this scenario, that's a very obvious choice. First of all, there's only 2 shards, and second of all, this is our original shard. This is where we inserted all of our data. It's got 500 chunks more than shard 2, so that's an easy bit. It's going to move chunks from shard 1 to shard 2 and keep doing so until it gets balanced. But how is it going to pick a chunk? Well, if you remember correctly, the criteria it uses is it looks for the lowest range. So this is going to be your oldest chunk. That's the first one that gets moved over. The second one is going to be your second oldest. And this will continue on until you've basically got your 250 newest, 250 oldest. Then you come along and you say, okay, it's time to clean up my data. I don't need anything older than 6 months. As just by coincidence, 6 months of data is approximately equal to 250 chunks. I know, what are the odds, right? So you're in your 2 shard solution, everything is balanced. You're like, great, I've taken the pressure off shard 1, I've got my shard 2 here, it's humming away. I know that I'm going to clean up here, I'm going to get rid of that 6 months data, I'm just going to delete all that. And so what you're going to do is delete all data in shard 2. It'll still have 250 chunks because they don't go anywhere. It's just a metadata description. They just all happen to be empty. So by picking a time-based shard key, filling it up, moving it over, all the old ones get moved over because they're the ones with the lowest ranges, and then deleting all of your old data, you've essentially created a scenario where, although the balancer thinks that everything's balanced, we've got 250 here and we've got 250 here, you have 0 data on shard 2. So there's an empty chunks dilemma that can cause some problems. There are other ways to end up in this particular scenario, but this is probably the one I've seen most often, and kind of a common pitfall that people fall into. What can you do about empty chunks? Well, there's not a lot to be done if you've already picked your shard key and you've run into that scenario that I described before. However, what you can do is stop the balancer and manually move chunks, which I've already done in an example, so I won't repeat that. But you'd have to go through and pick chunks with specific amounts of data and move them over. And then as an addition in 2.6 plus, there's been a command added called merge chunk. And here's a quick look at that particular command: ability to merge co-located contiguous chunks. Merge chunks provides the ability to combine contiguous chunks located on a single shard. Now, the interesting limitation to merge chunks is that it has a couple of requirements. One, it can only merge chunks that, one, are on the shard. Two, that are contiguous. So when you want to merge two chunks, they have to have contiguous ranges. They have to be next to each other in the list, if you like. So contiguous ranges only. And then finally, one or both must be empty. So merge chunk will let you get rid of some of these empty chunks, consolidate them down, but only if they're empty. One or both of the chunks in question are empty. So that would then give the balancer the clue that it needs that there is actually an imbalance, and it would start rebalancing then again. If you don't have the two chunks that you want to merge in the same shard, you're back to manually moving them. Eventually the merge chunk command may contain options to move chunks from one shard to another and then merge them and do some more complex operations. But for a first pass, we've kept it very, very simple. Merging an empty chunk with an existing chunk, and that's it.